Okay, let's get started. And I'm going to bring up the course web page. And let's take a look at where we are right now in the schedule. So there's reading 1, reading 2 should be completed by today. And now we're working on lab 2. And so that will complete by Wednesday. So what I want to do today is talk about lab 2, actually demonstrate it, and then talk about it while I'm demonstrating it. Let's see, before I jump in there, very quickly, reading 2. And understand, these are the learning objectives, and I'm not just going to sit here and read them off. Let's talk about them in the context of our problem. But to tell you the truth, these learning objectives really don't come into play very strongly in Lab 2. They come into play in Lab 3 and all subsequent work that we do. But we'll cover these topics and these items as they arise. Let's take a look at Lab 2. I also want to add that I started making some changes to the course. I don't know if anybody noticed it, but I'm removing the graphics programming problems that I had in there at the beginning, and I'm replacing them with console-only programs. So that should simplify your lives, and in the sense that you don't need to include the library that comes with the textbook, the graphics library that comes with the textbook. So it's going to make it easier to build the project, to assemble the pieces that you need. And also, it'll enable you to work remotely using just the console window. So you can use SSH and connect to a lab machine and do all your work anywhere that you have an SSH client, which is easy to get, by the way, easy to install. And let's go over that again today. What do I mean by SSH client? How do we log into a lab machine? How do we do our work? How do we build? How do we write programs in that environment? And the other thing that we're going to talk about today is subversion. So we're going to start practicing the procedures to read and write from and to your subversion repository. All right. So I will have already sent you an email, and in the email I provided you with an SVN or subversion username and password. So if you didn't get that email, or you lost it, or it's not working for you, then you should talk to me as soon as possible, so I can fix those problems in lab today. All right, so what I'll do is focus on the Linux-based solution, which is the solution that you can, which is the procedure that you can do wherever you are, whether you're in the lab or whether you're at home, whether on a Macintosh computer, and so on. All right, let's take a look here. First off, let me talk about, I'm going to spend some time talking about the repository and the source code repository that we will all individually use to commit our work. And as you can see here, this is a URL, which is it's a web address to a resource on the internet or on the World Wide Web. And this part of that string you need to replace with the username that I gave you in the email. Let's take a look at that. So it's protected. It's over HTTPS, but you'll see it's crossed out because this is a web server that I set up, and I did not pay for a certificate. Right? They're not free. So I did not pay for a certificate that the browser recognizes as valid. To get one of those, you have to pay for it. I did generate a certificate called a self-signed certificate, but those type of certificates are not they're not recognized by browsers as being trusted. So there's a warning here. I'm going to proceed anyway. And this is the username and password that I gave you in the email, not the username and password that you use in the lab. Okay, this is a different username and password. And so we see here's a web page. This is the name of the repository. And this is the revision number. It's revision 0. In other words, there's nothing in there. I haven't stored anything in there yet. So it's empty. So your repository will look like this. Now all right, let's go ahead and log into one of the lab machines. And let's see, I think I have some explanation of how to do that somewhere. Let's see if I can find it. Did I have it in lab 1? No, I did not put it there. Did I put it in notes? There it is. I just added these. So this is an explanation of how to connect to a lab machine from outside the lab. This is called a host name. So in computer language, when you hear the word host, what do you think of? What you should think of, computer. That's all it is. It's just a computer. Actually, it's a computer that's connected to a network. So I'm going to connect to the host. It means I'm going to connect to the computer. And this is the address or the name, the qualified name of the host that we need to connect to. This is the name of the host locally on its on what's called its DNS domain. And this is the DNS domain that host's name is recognized under. And so this is called the fully qualified domain name of that host that you should connect to. So I'm going to copy that. And let's go ahead. Oh, that's not what I need. So on Windows, I use putty. There are other SSH client programs that you can use. Putty is free, and it's widely used, and that's what I use. So there's a spot here, a box for the host name, or you could also enter the IP address as well. I'm going to put that in there and open. Now this is the username and password that you have to log into the lab machines. It's not the username and password for the repository. Okay, I'm logged in. Let me see if I have a CSE201 directory. I have that already. And I'm just going to delete what's in there. Once again, this command is very dangerous. You can wipe out your home directory if you execute this in the wrong place. So just to back up, from the last lab, I'm going to remove the directory called 201. These are the... Oh, it's not empty. Let's see what's in CSE201. Oh, like that. This command did not erase the .svn folder. So I was experimenting, making sure the repository is working. And this rm command did not delete that. And I believe the reason why is because that folder has a name that starts with a dot, and that's an indication under Linux and Macintosh that the folder should be hidden. So it shouldn't be dealt with in the normal way when users interact with the file system. So let's try to delete that folder, or remove it rather. Oh no, delete it. Let's delete it. Let's delete it directly. Let's see if it takes it. So -a means all, show everything including the hidden files. Okay, there's nothing there. Well, you see a dot and a dot dot, right? The dot means the folder itself, and the dot dot means the parent. So every folder has a dot and a dot dot in it. That's true on Windows as well. So I'm just reviewing some of the commands that you learned last time. You can remove a directory which is empty using rmdir command. That's the same on Windows. And you can make a directory with mkdir. And so this is essentially where you're at right now, right? You made a directory and experimented with it. Actually, let me repeat lab 1 really quickly here. What did you do for lab 1? Was it the did you create a subfolder in there called lab 1? Is that right? Okay, so let me just do that then. So we make a directory called lab. Was it like this? Did I ask for something like named specifically like that? What's that? I can't hear. Oh, Sam. I think I used Sam, right? Well, I recommend today that you delete everything that's in there. And also there was I had you write a program, stored in a file called hello, I think it was. And just copy that program from here. I added this because on Visual Studio it's good when you're running in debug mode to have this. And we can I could leave it there for now, I guess. So we create a file called hello.cpp. Then we can look at it. It's in the file system, and then we can build it. Oop. This is the same problem we had last time. So some commands don't work on JBH3-1, and I completely forgot that the system administrator doesn't want us all working on one computer. So we need to hop. We need to do an extra hop now. We're on JBH3-1. We need to move to a machine that's in the lab. And I have that written up here under notes. Right, first connect here, and then connect to one of the lab machines. And because we're already in this domain, this DNS domain, we don't need to give the whole path when hopping to another machine. So let's do that. And I'll just change that to something else, like say 14. Oops, 2 SSHs there. It says the authenticity of the host can't be established. Are you sure you want to connect? And I say yes. And so as you can see, now we're logged into JB359-14. We can see if anyone else is on that machine. No, it's just me. And now to exit that machine, we just type in exit. You look at the prompt. We're in JB359-14. Now we're back to JBH3-1. And let's go back in again. As you can see, the second time you go in, it doesn't warn you about the host being unknown, because now it's known. Now we said trust it. Now we know it. We entered our password, and now it caches that information into a file and uses it. All right. Let's go into the folder 201. And inside there is Sam. Let's go into Sam. And let's go ahead and build the program. Now it works. And there it generated the file a.out, and it shows it in green. And I'm going to use the -l long list. And the reason it's displayed in green is because this X right here, see the three X's, the X, X, X. That's called the execute bit. It says that it gives permission to the operating system to execute that file, to load the machine instructions in that file into RAM, and then and set the program pointer to an entry point instruction that runs inside that block of machine instructions. That's what goes on in the background. Let's run it. /a.out, and there it is, by. And that's that. That's what we did essentially last time. Then we experimented with some different commands, operating system commands called console commands. Any questions at this point about that material from Lab 1 and what I've done so far? And by the way, we're working on a machine in the lab right now, and we're communicating with it through an intermediate computer called JBH3-1. So, and then we're also locally here. So we've got like 3 computers right now, and that middle one is just channeling our communication messages. And this is a typical scenario when in IT, when you're managing computers. It's also a typical scenario for criminals who attack computer networks. And that in order to disguise where they're coming from, they will go through many intermediate hosts, many intermediate computers. So you have to trace back, oh, I see, the data's coming from this, and let's go to their network and look, where is it coming from? It's coming from China. Oh, let's go, it's coming from, Afghanistan. Oh, I see, it's coming from the UK. And so you could have some of these attackers will go through many, many hosts before they get to that end machine that they are trying to do the dirty work on. And outside of criminal activity, this kind of hopping is also common in system administration environments, because you need to pass. Things are hidden behind firewalls, and they're sitting in private networks, so you have to find your way into these places. So basically, you're creating these intermediate points that you can pass through. All right, let's go forward. Now, I would just normally delete the SAM folder now and start from scratch. That's what I recommend that you do. But I'm just going to just to show you what would happen, I'm going to leave that in there, and just in case this is your situation. No, I think I changed my mind. I'm going to delete it. Let's kill that folder. And now this folder is empty. Let's check out our empty repository. So it's svn-co for checkout. And you could spell it out as well. That's equivalent. So svn for subversion, checkout, and then just paste in the, oh, wait a minute, not yet. I'm going to do it like this. I'm going to go up a level, just outside of CSE201, just above it in the parent folder, and I'm going to do the checkout there. So the second argument is the subversion command. The third argument, the first argument is CO, which is checkout. The second argument is the URL, and the third argument is the folder to write the working copy into. Now when you do this, it'll probably ask you for username and password, and that's the username and password that you need for accessing the repository, not the username and password for logging into the the lab machine. If I do ls, whoops, sorry, let's cd into 201, do ls, and there's nothing there. If I do ls minus a, oh, there's a .svn. So there's a folder named .svn that contains files that are used to manage this, the relationship between the working copy and the copy that's on the server. So we can actually look in there, .svn. It's a folder, and there you can see there's subfolders in there as well as files. There's a lot of information in there. So you'd never modify this .svn folder directly. That's maintained by the command line client, the svn command. So that's a program, svn. When we run that at the command line, it will read the .svn folder and modify it. All right, let's do lab 2. So let's create a folder called lab 021. Actually, what we're going to do, we're not going to create a folder for each lab. We'll create a folder for each programming problem that we solve. So there's 2 programming problems in lab 2, problem 1 and problem 2. So we'll create a folder for the first programming problem. And let's find out what that is. Let's see, that's lab 2. So here are the notes, what we just did. Okay. Write a console program that prompts the user for their name and then displays the sentence, hello, user's name, nice to meet you. So when I run it, I'll type in Dave, and it'll say, hello, Dave, nice to meet you. All right, let's do that. And that's similar to that starter code that we did in lab 1, right? So let's go back to lab 1, grab that starting point code right here. So we need to create a file, and it should end with .cpp, and then paste that text into it that I copied from the web page. But the question now is, how do we create that file? How do we put the text in there? So we need to use a text editor. Does anyone have a suggestion? I've been using VI. I don't recommend VI in general. Back there, suggestion? What's that? Oh, VI. You see, VI is a very old program, and it's complex and it's complicated, and it's good for the computer science students to learn it, and it's good for system administrators to learn it because it's essentially everywhere. It's on Macintosh, it's on Linux. It's not on Windows, though.
Or touch on a MacBook.
What's that?
Or touch on a MacBook. Touch file name.
Oh, touch?
Yeah.
No, touch, that just updates the file, like the last update value on the file, doesn't it?
No, it actually opens up a text edit.
Oh, really?
Yeah.
Touch, the word touch?
So it's touch instead of gedit.
Oh, I see.
Yeah.
Now, gedit, you can't use gedit here because gedit needs a graphics window to run in. But we're making a console connection. In the lab, we can use gedit, but we can't use it here when we're using SSH. You want to try it? I don't know what's going to happen. Well, let's try it. Oh, cannot open display, right? They can't. We're not running in we're not running in an instance of what's called the shell or the console or the login. It's called a login shell. We're not running in an instance of a login shell that is associated with a graphics device, graphics output device. We can't run it. All right. I think there's Pico. I think there's a program called Pico. Let's see. No. How about Nano? That works. Let's try this. This is more intuitive. So for those people who don't want to learn VI, and it's hard to learn VI, but I do recommend it actually if you want to learn that. And you know, we're not on Windows, so we don't really need this. Let's see, how can I delete that line? See, in VI it's very fast. I can delete that immediately, but in this intuitive program it takes more time. All right, so just get rid of that line. It says bye. So it'll be, we're going to write a program that says hello, and you know, hello, Dave. Let's do it like that. So it'll be something like, hello, Dave. Nice to meet you. Is that what I asked for? So let's see, Control O to write out. So I'm going to see that down there, that caret symbol with an O. So I'm going to hold down the Control key. That's that angle, and write that. File name to write, main.cpp. Well, that's what I entered on the command line, so it's assuming that that's the name of the file that we want. So let's hit enter on that. And then let's see, to exit, Control X down here. Let's try that. Okay, that was painless. That's easier than using VI. But I'm going to use VI in the class because I can type faster with VI. But you may want to use Nano. Let's take a look. We have main.cpp in here. Let's go ahead and build that. ls, there's an a dot out. Hello, Dave, nice to meet you. Look at the prompt came right after that line. So I forgot to put in a new line character when we wrote into the output stream. Let's fix that. We're going to add that in there. So it's \n. See, the backslash means, you know, we're inside of a string. This is called a string literal. It's not a variable. It's not a function. It doesn't represent functionality. It's just this is just an indication to the compiler that we've got some data here. This is the data itself. This is not a variable representing data that's somewhere else. This is the data. We call it a string literal. It's literally what it is. Whereas this thing here, that's an identifier that represents an instance of an object, an instance of a class rather. It's an object that's predefined, and it's defined in this header somehow. It's not defined in the header. It's declared in the header and defined in part of the standard library. So in this string, so we're telling the compiler that when the program runs, when it gets to this point in the execution of our program, and well, there's only one statement in our program. The programs are collections of statements, and this is a statement. Actually, this is a function. We're going to cover functions in chapter 4. I don't remember, but one of the chapters talks about what a function is. Essentially, a function, it's a named block of code, it's a block of logic, a block of instructions. A function is a collection of instructions, a sequence of instructions that can be run. And we use the name of the function to initiate the execution of those instructions. Now, these instructions are delimited with braces. So you have an opening brace here, you have a closing brace there, and in between the opening and closing brace you have 0 or more statements. And in C++, a statement ends with a semicolon. You see it right there. So I know that's a statement. And the name of the function is main. So when we want the statements in main to run, we use the identifier main in some way to initiate the execution of the statements in main. But main is special. It's a special function. It's the entry point. So when the compiler compiles the source code, it looks for main and says, I got to find a main here because that's where I'm going to start executing your program when you tell me to run it. So we need to define a main. Once again, this is a topic that comes a little bit later in the class, chapter 4 or something like that, 4 or 5. But we need to, in the beginning, start working inside this main function. But we won't use any other, we won't define any other functions, but we'll use functions. We'll use functions that are predefined, but we won't define any until we get to that later chapter. All right, so the string, hello Dave, nice to meet you once again. We just modified the string. We opened the editor. We added a \n. This is a list of characters. Question?
Yes. So for when we're gonna use main, do we need what's inside the parentheses, int, arg, or
Do we need int main like that? Can we omit int?
whatever is in?
Can we omit? Those are called arguments. Can we omit the arguments? Int argc. On many compilers, you can omit these arguments. On some compilers, you cannot omit these arguments.
How about those in the lab?
Probably you can, well, here we are. Let's try it. Let's try it. And watch, I'm just going to, I'm going to comment out, // is a comment. See that? It's commented out the line. I wanted to save it. And let's go ahead and delete the arguments and see if it builds. Because we're in the lab. We're in the lab. We're on a lab computer. Let's see if that runs. Now, we need to compile again. It compiled. It didn't complain. And let's run it. And now it breaks. We have that, the end of line character in there. Now it breaks nicely. Now let's take a look. Let's suppose we called this k main. Okay, so there's no main now. There's a k main. Let's try to build that. Undefined reference to main. So the compiler is searching for, the compiler assumes that a main exists, and it says, well, wait a minute. When I go to link, so the problem is in linking. The system actually compiled. It actually compiled the code. It generated machine instructions for main.cpp. But after you generate the machine instructions, you do the system or the compiler does another step. It's called linking. And it looks in the machine instructions and it says, okay, you've got references to operating system calls, and let's resolve those. You've got references to calls into the C library. Let's resolve those. And so it has to do some extra wiring to get things to work. And then it says, okay, we got to have a main for you, but I can't find it in the set of machine instructions that you just generated. So it's saying, oh, hey, wait a minute, main is undefined. So it says undefined reference to main. I think you can also remove this. Maybe it won't let this happen. Let's see if it lets us void instead of int. Because int means we're returning an integer. Void means we're not returning anything. Now some compilers will accept this. Nope. Error. Main with a, I don't know why it's got that A like that. Main must return int. Oh, I know why this. See, it's the terminal window, the terminal program that we're using, the character sets don't mesh correctly. So this, see this A hat here? It should be probably a quote, but the remote system is sending numbers in a different character set than the terminal is assuming. And so the value that it's sending for the quote, it thinks is a quote, you know, this terminal program thinks is a hat. Now, I'm not going to look at that right now. I'm not going to worry about it. So it doesn't take a void. It needs an int there. And in fact, what gets what's being done there is we're really returning 0. The compiler, normally if you have a function that's declared as returning an int and you don't return anything, then that will be a compilation error. But compilers let you get away with not returning a value for main. They assume you want to return a 0. And a 0, by convention, means the program terminated normally. So this is a value you return to the operating system, the component of the operating system that launched you. You send back a 0, and that's an indication that everything went okay. If you want to tell the invoker that something was wrong, then you return something that's non-zero, like a 1 or 1100. That could be an error code. Then the person might need to look up the error code in a list to find out what's wrong. But the convention is to return a 0 when everything is okay. A lot of system administration scripts are written to read that value. So system administrators write commands, the sequences of commands to do different operations. And each time that they run a command, they want to look at the return value to see if the command is telling you whether the operation completed normally or whether there was some problem. And if there was a problem, maybe we don't want to keep we don't want to keep running the script. We want to stop and alert the system administrator something's wrong. That's the convention. All right, now what we need to do is we want the user to type in the name, Dave, right? Or Abby or something, so that we can greet that specific user. We don't want to just keep greeting Dave all the time. So I'm going to solve this problem in stages, in steps. And I know that I need to insert this piece of the string has to be replaced by what the user types in. So I'm going to show you how I would do it. In the next step, I would terminate the string here. And then I would print out what the user typed in. And then I would print out the rest of this. Let's see if that runs. Let's test it before we do any more. Hello, Dave. Nice to meet you. So it's the same result. That's good. All right, so that works. So now what we need to do is we need to have a string called to say something like name. This string represents what the user will type in. And rather than typing this string specifically, the string literal, let's tell this operator here, this is called the output operator. Let's tell that operator that we want that it get the string to output from the from what the identifier name represents. They call it a variable. So name is a variable. It's like in algebra, in math, you have x equals 2. Okay, so I'm going to say print x. Well, I print a 2. Oh, let's change x. Let's make x 3. Now, it's the same print x. I didn't modify the statement print x, but now it prints a 3. That's because the expression print x is based on something that's variable, something whose value can change. So let's see if this compiles. It might not compile because I didn't put the string header in there. It worked. Some compilers wouldn't like, well actually, I think it'll run on most compilers. Hello Dave, nice to meet you. All right. So let's suppose let's just imagine, oh, the user just typed in Dave. Now let's have another user. Now the user types in Alice. So we're pretending that we're getting that information from the user. We don't know how to do it yet. We're just getting ready for that moment when we do know how to do it. Once again, we need to compile and run it again. Okay, hello Alice, nice to meet you. Okay, so we have a variable. We have something that whose state can change. So we have something, this name is a variable. It represents something that could be different at different different situations. So now how do we get the string from the user through the console? So we're going to do it like this. We're going to use this object here. It's called cin. It's called, I don't know why I call it C, but it's made for the C language. But it's a standard input stream. It's the complement to cout. Cout is a variable that represents the standard output stream. Now the standard output stream, that's where when you do write commands, that's where stuff go, the output stream. And the output stream can be changed. So we can make the output stream a file, and the things that are written into cout will then go into a file. But right now, we're using the default assignment of the output stream to the console. So things are displayed on the console. So we have, I'm going to illustrate that to you actually, because we're going to use that in Lab 3, that concept. So we're not changing anything. I'll build it again. You see, when I run the program and we do cout, that string, that the characters are written into the standard output string, which is now assigned to the console. So we see it in the console, but we can redirect the output to a file. Let's call it test.txt. Watch, if I run it again, oh, it doesn't show anything. That's because we reassigned a standard output stream to that file test.txt. And look, it created test.txt. And we can look inside test.txt to see, oh, there's the string. That's the string that we wrote into the standard output stream. And we will use this technique throughout the course, starting in Lab 3. So I'm going to remove that. I like to keep things cleaned up. All right, once again, let's come back to the problem of how do we now, we've got this concept of a standard output stream. Now we also have the complement concept, which is a standard input stream. How do we get what we need? How do we get the name from the standard input stream? Well, we use cin. And this is called the output operator, but oh, the other way around, that's called the input operator. So we're going to read out of cin, and we'll store that inside the variable name. So even though we set the the name up here to Alice, we're going to change it to what the user enters in. By the way, I'm using the up and down arrow key to go through the history. It's called the history, command history. So it's very convenient to have these up and down arrows that can go through the command history. And so we just compiled. And let's just run it by itself here. A.out. Oh, look, it's waiting. It's not. It's paused. It's not. It has the program is running, but it's blocking. It's called blocking. It's waiting for us to enter something, and I'm going to type in Bob. It's still waiting. It's waiting for me to hit enter. And now it says, hello, Bob. Nice to meet you. See, that C in makes the program pause. We say block. It's called a blocking call, a blocking operation. It stops the program. It says, okay, I did this input operation, and I'm just going to sleep until that someone else is taking care of that job. And when they're finished that work, they're going to return back to me. And of course, part of the job is to fill that variable in with a new value, which it did. And we don't need to initialize this. Actually, this expression right here creates a string called name, and its initial state is empty. It's an empty string, a string with 0 characters. Now, it's a little hard to understand when the program runs what to do. So let's put a prompt in there for the user. We'll do this. Cout, what is your name? And I'm going to put a new line in there. And let's see if that runs a little better. What is your name? I won't use Alice. Let me use Claire. Hello, Claire. Nice to meet you. And that's it. There's a concept of variable, concept of input-output streams, compilation, runtime, machine instructions, executable, functions. We don't have to know functions that well yet, you know. Just put that one on hold, but there is something called a function going on here. Also, this business up here, this is the header file, and this imports all the names in namespace std to make them local. And I'll explain what that means. Let's go ahead and investigate those two items there. And also I want to talk about these arguments. Do we have time? It's 12:50. Huh? 12:51. Just in case we don't have time, I'm going to do the subversion commit operation now. And then we'll continue on and talk more about this program, and then we'll quit. Okay? So let's commit our work. So we're done lab 02. So what I recommend for you to do, and there's different ways of doing this, so you have to be careful. I recommend that you go up to this PWD, print working directory, that you go up to this CSE201 folder, and then do svn space add, and then we just add in that folder. Or you can use a star that says get everything. And as you can see, it says add, add, add. The A's mean add. So it's going to add the folder, and it's going to add the main that's in the folder, and it's going to add the A.out that's in there. And we really don't need the A.out in there. But I'm going to be sloppy. I'm just going to leave it there, because Many of you aren't going to clean that up. You're just going to leave that in there as well. So I'm just going to show you what it looks like with the minimum amount of work. Um, but now it's not in the repository yet. I just did svn add, but svn add doesn't do anything. It doesn't talk to the server. We're still at revision 0 on the server. What we need to do is commit the changes. So when we did svn add, we scheduled 3 objects to be added to the server, to the remote repository, but we didn't actually do it yet. And you need to specify a comment. Oops. It's lab 2, exercise 1. So I've got -m space and a string that's in quotes. And that's a comment. And I'll show you what happens if you don't put the comment in there. It did it. Committed, revision 1. Let's go to the web page. Oh, it still says revision 0. Well, this is a stale web page. Because the web page is not a dynamic thing. It's just we retrieve it from the server and then we have it. So what we have here is something that we got from the server at the beginning of class, not what we would get now. So to get what we need, what's there now, we're going to hit refresh. There's revision 1. Oh, there's a folder. There's the a.out. Oh, that's an executable. It's just downloading it. Well, we don't need that. I click on main.cpp. We can see our work there. So I want you to go in your browser to your repository and verify that the work you think you committed is actually there. Because in many cases, you did something wrong, the commit may have failed, and you didn't notice the message, the tiny little message that said the commit failed. You didn't notice it. But when you went to the repository to check to see if your work was there, you noticed it wasn't there. So then you can go back and troubleshoot at that point. Now when you do lab 2, you're going to make another directory here. This is lab underscore 022. I'm sorry, the exercise 2 from lab 2. Let's make that. Let's go in there and work. And it'll be another main. And we'll just type something in there, whatever it is. And we work on that. Okay. And now it's time to commit our work. So we go up to here, and I'm going to go svn commit. I'm doing it wrong. Okay, I'm doing it wrong here. And lab 2, exercise 2. Oh, it didn't say anything. It's not there. So some people are going to do this. Because you forgot, we didn't add it. We need to add it. svn add. And I'll be lazy. I'll just add everything. Oops. And it's warning, hey, lab 021, that's already in there. So, you know, that's just, you're giving me a command to do more than I need to know. So it's scheduled these two adds here, the folder 022 and the object that's inside of it. Now let's go ahead and commit it. Well, what happens if we don't use the -m? Oh. Commit failed. This isn't exactly what I expected, but it's not bad. It's good. So could not use external editor to fetch log message. Consider setting the svn editor environment variable or using the -message or -m options. So it looks like it's giving you something there. the environment variable. I'm going to look at my environment variables here. Do I have SVN editor? Whoops, that should be echo. I didn't make the same mistake. There's something called an environment, and in the environment you've got some name value pairs. You've got some properties. And many programs will look at for values in the environment to modify its behavior. So I'm just going to leave it like this. You can set this environmental variable called SVN editor, and then it'll open VI or Nano or whatever editor you want to use if you forget to put in the -m option. I think it's easier just to use -m. All right, let's go ahead and we did this, right? Yeah, let's do it again. This time we've got -m. And added it. No error messages like up here. See, when you get this and it says commit failed, you have to do something. Don't just look away and say I'm done. You got to attend to the problem. This was a successful commit. And I'm going to refresh the web page. There's O2, and there's our beginning of our next assignment there. Any questions about what I've done so far? Yeah. Can you remove a file? Yeah, let's do that. Let's CD into this lab. That should be very nice if you remove the a.outs. Because it makes the consumption of storage on the server less. So we don't want to just remove. This would be a mistake here. We don't want to just remove it. We need to remove through subversion. Because if we remove outside of subversion, then subversion won't know what's going on. Huh? So let's use SVN and remove a.out. See, there's the D, which is like an A, but now it's delete. And now I recommend going up to the parent folder and do the commit from there, but let's do the commit from down here, just to see what goes on. So we're going to commit. This is what I do a lot. I put an empty string in there because I don't need a comment from you. It's good habit to put in comments when you do a commit, but especially when you're working on a real project. But I don't need to see the comment, although you can put them in there if you want. Now it's deleting. So now we go back to here and go back into lab 0201. Now the a.out is gone. You could also tell the system to ignore certain files. So you could say to ignore a.out, and there's a command for that. It's a little cryptic, though. I'm not going to show it to you now because I don't remember it. I'd have to look it up, first of all. But when you're using a GUI-based subversion client, then things like telling it to ignore certain file types is easier to do. You don't have to remember the command line form of that operation. So we're doing things from the command line. And there are graphical programs that let you do this graphically rather than issuing commands from the command line. All right, let's go back. Any other questions on this? Okay.
Yeah, I did have a question. On the first exercise, wouldn't it be best to have 4 instructions? Please enter your first name and then press enter as one string. CN the name, and then store that name, and then C out the name and the string.
That's okay. You can do it in different ways, and that way is fine. Yeah. Whatever you think is more. So you're concerned about how readable the code is?
No, so when the person goes to use it, they actually know what to do.
Oh, hello. What is your name? Or please enter your name.
Yeah.
Yeah, you can give more specific instructions to the user. Yeah, that's right. I mean, but normally real users are not using a command line. This is kind of an artificial example here. System administrators are using the command line to run programs, or programmers using the command line to run programmers. And the programmers are going to run those programs in certain situations, and so it's not going to be like your general, it's not like a user on the internet who's going to use your program and you have to accommodate a large group of users. We're just writing some tool here. So we don't really know who our users will be. So we don't know how to accommodate them. It's an artificial problem.
Okay.
Yeah. But it's a very good habit to start thinking about how the user is going to understand your interface, your program, how to interact with it. And we are not covering that topic in this class. So that concern is not a topic that we're covering. Because what users are going to use a command line to run your program in a command line? I mean, very few users. And it'll be very special cases. Maybe some scientific computing somewhere. You've got a small number of people running a program that you wrote at the command line. But in that situation, then you want to be very careful and prompt the user correctly and so on. When I was younger, it was common. Everything was run at the command line. There was no such thing as a graphical user interface. They didn't have graphics. Everything was text. And in that case, that was a big concern, right? And we had to spend a lot of time on that issue, but not now. All right, let's we're near the end here, right? We finish at 1:15. I could go on about what this is, what this is and what this is. Do you want to do that now or break? I guess we break, right? That's enough for now. And we'll continue on Wednesday in lecture, and then the lab is this afternoon. If anyone is having specific problems, you can ask me now about it.
Hey, Professor.
Yeah.
Sorry.
Up, you're first.
I finally got your class added, so
Yeah.
I don't have the email and I filled out a sheet for the help desk to make me an
Yeah.
account.
Let me make a, did I create an account for you on the
I
server?
don't think so.
Here, wait a minute. Let me do it right now, okay, while you're here. Whoops, I need to stop that.